Indeed, thank you for the introduction, and thank you for the last talk. I really appreciate that, and in fact, it kind of moves into some of the areas that I wanted to talk about here, and that's soft boundaries in human-machine interfaces. So what am I talking about here? Well, what I'd like to do is I would like to see the world in a way. Let's see if I got this right. Haha. I would like to see the world in a way where we have more interconnectivity with the machines that we're using. Right now I'm holding two. They're unwieldy and hard. I probably should have chosen the other microphone system. But let's look at where some things are done well. So in fishing, I don't know if anybody are fly fishers out here, but you have some highly engineered devices here. I mean, sure, you got a string on a pole, but dependent upon the materials within that pole, the length of that pole, the modulus of the string, the strength of the reel, you have a system that enhances your own feeling. So when you have a fish grab, you absolutely feel it, and it's all due to the engineering of the materials that you're holding. It's a tactile experience, and it can't necessarily work as well another way if you've tried catching a fish with just a basic stick and a string. Another experience would be that of driving. Of course, we have our visual sensation, keep your eyes on the road, keep your ears open, but the car itself pushes back into you. So as you accelerate, you're forced back into your seat. As you turn into a curve, depending upon the banking of the curves, you feel it in your steering wheel. You feel it fight against you to stay into the groove that you've set. Even more so, we can get into the complex machinery. These give you a lot of indications that are, outside of the experience of what we normally get to play around with. But you get a feel for the system, and that interaction that you have with the machine tells you how to operate the machine. An area that we feel is doing it well at LiquidWire is the area of gaming and training. All of your modern computer controller systems and video game control systems are going to have some sort of haptic feedback response. You're going to have some sort of pushback against the way that you are trying to control something to give you a feel of what you're doing. You also get the, totally brought-in environment in the VR space. But there are a lot of places that do this badly. And unfortunately, these are the ones that are really common to us. So in any modern vehicle, you're looking at a display that is controlling your infotainment. Nothing wrong if anybody here is an infotainment maker. But it's not pleasing in that, remember the old devices? You turn a dial, you feel the dial. The dial pushes back against you. It has detents, specifically set detents. You push buttons, the buttons push back. You feel them, you know them, you can do it without looking. Unfortunately, our infotainment systems don't necessarily have that sort of feedback in on them. So you feel it, you touch it, maybe it works, maybe it doesn't. When we get into other areas like the medical device arena, you have nurses that are trained, nurses, doctors, the entire medical staff that are trained for what is being displayed on a medical display that you see in the center there. And this takes a long time to train a person up to. They're getting very complex information that is of literally vital importance. Finally, I've got a mission control. There's so many screens, but the only way that humans are interacting with machines and the way that machines are interacting with humans in these cases are A, by your visual acuity, and B, by the interfacing that I'm doing right now. I'm holding